Hello. Today, ACS is part of enterprise's network infrastructure. Administering its components, along with other network devices at facility, falls under system administrators. Nowadays, even at small enterprises, a single network can have a huge number of devices, so it's important to monitor the status of all network elements to prevent or resolve potential issues. The standard practice is to use specialized monitoring software for this, such as NAGES, NPM, and PRDG, Zabbix, and many others. The main tool in these systems is the SNMP protocol. Let's break it down in detail. SNMP, or Simple Network Management Protocol, is a standard protocol used for managing and monitoring network devices, such as routers, switches, servers, and other network components, including ACS controllers. With SNMP, you can obtain information about the status of locks, readers, controllers, and other elements of the system. Such monitoring allows you to respond quickly to events, detect, and resolve potential issues. Today, we'll go over how to set up monitoring of system elements using the SNMP protocol. As an example, we'll look at configuring this with a popular monitoring system called Zabbix. First, let's go over the necessary settings on the Zabbix server side. First of all, we need to install the Zabbix server and configure it to work with devices that support SNMP. After installing and configuring the server, we can move on to setting up monitoring for probably one of the most important elements of the access control system, the controller. In our case, this is the E2 model controller. To add a new device to the system server, in the Zabbix interface, we go to the configuration section and then hosts. Then we select the create host option. In the window that appears, we specify the main parameters of our controller. Let's start with the host name. This parameter will reflect the name of our device, that is, the controller, within the Zabbix system. Visible name. This is a user-friendly host name displayed on the device monitoring screen. Next, we select the template that will be assigned to this host. It's important to note that this video is intended for experienced users and those who simply want to get acquainted with Sigur's capabilities and optimize the IT department's work regarding access control systems. For the first group, we prepared a special MIB file allowing more detailed template configuration, enabling the monitoring system to poll the controller about its relay's status, discrete inputs, OSDP connection status, readers, and much more. Additionally, we created a ready-made Sigur template including the main parameters that, in our opinion, will be of primary interest for monitoring. Using it in your system setup will save you a lot of time and make configuration much more convenient. Let's figure out what a template is in a Zabbix system. Imagine you have several network devices, such as routers, switches, or servers, whose status you need to monitor. Each of these devices may have its own set of metrics and parameters that are of interest to you. For example, in the case of ACS controllers, this could be connection status, power voltage, relay or input status, emergency unlock, and much more. You can see the full list of all metrics and parameters on the screen. Instead of setting up monitoring for each device separately, you can create a template in Zabbix that defines which metrics should be monitored for each type of device. The template contains pre-configured monitoring items, trigger conditions, and notification settings. You can find the download link in the video description or in the service section under download distributions on the official Sigur website. Let's go back to configuring the network node and select a group by clicking select or entering a new group name. It's important all access rights in Zabbix are assigned to a network node group, not individually, so a network node must belong to one group. Next, you need to specify the interface. Network nodes support several types of interfaces, but we're specifically interested in SNMP. Then, enter the controller's IP address and the port to connect to it. When setting up a new network node, you also need to select the protocol version. There are several working versions of SNMP. Most often, version 2 and version 3 are used. We won't go into the details of the differences between them in this video. But overall, SNMP version 3 offers a higher level of security and more options for access management and data control than SNMP version 2. This makes the third version the preferred choice for modern network environments and helps ensure reliability, and confidentiality when managing and monitoring network devices. Right after selecting the protocol, we need to specify additional parameters to ensure a secure connection between the monitoring system and our controller. Let's look at these parameters. The context name, or the name of our device, is used to identify a data element in the SNMP subnet. Let's enter a clear name for the controller. The security name field is required for connecting user macros in the Zabbix system. You can find more details about this in the official monitoring system administration documentation. Security level. Select a level that uses both the authentication protocol and the security protocol. Now let's specify the authentication protocol. Select SHA-1. This is a data encryption protocol that ensures the security and integrity of information. In the standard connection settings for the monitoring system, the Sigur controller uses this exact protocol. Next, let's specify the security protocol. Select AES-128. This is a popular encryption algorithm, has not been broken by attack. It will ensure the security of data transfer between the controller and the monitoring system. Choose a security passphrase, a password authorization using AES algorithm. At the end, be sure to check the activated box to make the network node active. In other words, ready for monitoring. With this, the minimum set of settings required to connect Zabbix to our controller is complete. So, after configuring the SNMP parameters, we can test the connection to the SCUD controller to make sure everything is working correctly. The Zabbix monitoring system has tools that allow you to check the connection to the device and get information about its status. To do this, go to the Monitoring tab and enter the name of our controller in the search bar. The status column will show the current connection status, and in the availability column, the SNMP icon will clearly indicate with color whether there is a connection to the device via this protocol. Green means yes, red means no, gray means unknown. Now you need to notify the controller about the connection to the monitoring system via the SNMP protocol. In other words, you need to specify the connection parameters for the external SNMP system to the SCUD controller, which we have already configured earlier in the Zabbix web interface. To do this, go to the Server Management program. Open the Device Settings tab. Next, click the Configure these devices button to view the list of available network devices. In the list, select the ACS controller you need and go to its parameters using the corresponding button. Here, on the right side of the window, we can configure the connection details for the external SNMP system to the controller. The parameters are divided into two groups depending on the SNMP protocol version used, version 3 or version 2. Let's look at both options separately. The first parameter allows us to specify the SNMP username. This username will be used for authentication when connecting to the SCUD controller. Let's enter the username. Next, we specify the authorization password and also the encryption password. The default port is set to 161. We did not change it. If you are using version 2 of the protocol, you can specify the IP address of the SNMP server that will be used to send SNMP requests from the monitoring system to the ACS controller. This allows the monitoring system to receive data about the controller's status and monitor its operation. And of course, we can specify the SNMP server port, where the monitoring system is running. This port also serves to establish communication and ensure proper routing of network traffic between devices. After specifying all the necessary connection parameters, we save the changes. Let's go back to the Zabbix server and check if a connection with our controller has been established. Now the monitoring system can successfully connect to the Sigur controller and receive information about its status using the SNMP protocol. Next, let's take a look. What kinds of tasks for a system administrator monitoring ACS components can be addressed with the functionality we set up? Earlier, during the setup process, we mentioned certain templates for device monitoring and specifically selected our ready-made template for Sigur controllers. It contains a set of predefined metrics and parameters that the controller can report to the monitoring system, and in turn, the system can respond to them in a specified way. For example, it can promptly send notifications to Telegram if emergency unlocking of access points is triggered on the controller due to a fire alarm loop activation, or if the voltage at the controller's power terminals drops below the normal level. You can find more details about configuring notifications for trigger events in the Zabbix monitoring system in the official system setup documentation. You can view the metrics that, according to our template, the controller sends to the Zabbix server in the monitoring system's web interface under the Configuration tab, then Templates, and then Template for Sigur controllers. To set up a response to a particular issue with the controller, you need to create a trigger on the Zabbix server. Let's look at the process of responding to a drop in the controller's power voltage. Go to the Configuration tab, then Templates, and then Triggers. Click the Create Trigger button. Enter its system name and, if necessary, a display name that will appear in the user interface. Next, specify the trigger severity and what priority the system responds to this event as specified. The expression, or what the trigger will be based on, and how the system will respond to it. Let's create it using the expression builder by clicking the corresponding button. In the expression builder, specify the data item, that is, the parameter that the controller reports to the Zabbix server and whose changes the system will respond to. In our case, it's the voltage. In the function menu, leave the parameter for the item's last value. In the for the last parameter, specify the number 3. This is the number of times the Zabbix server polls the device for this parameter's value before a reaction occurs. The default polling interval is already included in the template and is set to 1 minute. Optionally, you can change it in the template parameter settings. Let's specify the result, meaning the value of the parameter sent by the controller that will be considered the threshold for triggering a reaction after all polling attempts. For example, in the case of a voltage drop, the controller constantly sends its current voltage value to the monitoring server. Therefore, we can set a certain critical threshold as the result, for instance, less than 11 volts. Next, let's add a problem description so that our trigger in the system, as well as notifications in Telegram, look more informative. Be sure to check the Activated checkbox to activate this trigger. And to finish the setup, click the Add button. Now let's see how it works. We've already set up a test stand to simulate a drop in the controller's supply voltage, and we've reduced the polling interval for devices in the template so the response happens faster. Let's start gradually lowering the controller's supply voltage to the critical minimum. We hear the characteristic indicator sound. After 3 consecutive polls, the system identified the current issue, highlighted our device in red, and also sent notifications to Telegram. Explore the possibilities of optimizing the administration of SCUD network elements together with Sigur. That's all from me for now. Thank you for your attention, and see you next time.